Hello everyone, you're most welcome to the physics class. I hope all is well today. My name is Teacher Moses Odom, the physics teacher, who will be taking you through a very simple and interesting topic in physics, and that is the pressure. But specifically today, we are going to look at the sub-theme, which is the pressure in liquids. Last time we met, we talked about pressure in solid. Allow me review the previous class. Last time we defined pressure as the force acting normally per unit area. We went as far as stating the SI unit for pressure, and that is in Newton per meter square, which is the same as Pascal. We even looked at the formula that we can use to calculate pressure in solids. And we got it as the pressure equals to force over area. Now, today we are going to look at pressure in liquids. And class, since liquids takes up the shape of the container in which they are placed, the volume of liquids filling a container is equal to the volume of the container. Now let's consider a cylindrical container of cross-sectional area A, that is to say base area A, filled with a liquid of density rho to a height h, as shown below. Now we are going to realize that this container here is having the height h, and then the base area is A. Inside the container we have the liquid, whose density is supposed to be determined. Now, for now, we are going to calculate the volume of the liquid. And the volume of the liquid can simply be got from volume of the cylindrical container, since liquid takes up the shape of the container. Now, volume of liquid is got from area of circular base times height. And we are going to represent area of the circular base with letter A and then height with letter H. So in summary, volume of a liquid is going to be AH. Now that we know volume of the liquid, we can get mass of liquid. Mass of liquid is equals to density of liquid times volume of a liquid. Now, density of a liquid is rho, and then volume of the liquid is AH. Rho stands for density of the liquid. And now that we know density of the liquid as rho and the volume is AH, that means our mass is rho AH. We can quickly and smartly relate mass of the liquid and then weight of the liquid. You know very well that weight is the same as force. Now, force exerted by liquid is the same as weight of the liquid, and it can be got easily from mass times acceleration due to gravity. Now, force is equals to mass times acceleration due to gravity, and our mass, we got it as rho AH, and then acceleration due to gravity is g. Now, this gives us A h rho g. Now recall the formula that we used last time for pressure in solids, where we said pressure equals to force over area. Now we are going to substitute where there is force, we are going to put A h rho g, and where there is area, we are going to substitute it with letter A. And A in the numerator is the same as the very A in the numerator. They are all talking about area. So we are going to cancel them out. Then we remain with H rho G. So the formula that we are going to use today is the pressure equals to H rho G. That's the formula we use to calculate pressure in liquids. Now, allow me to take you through the factors affecting pressure in liquids. From the above derivations, pressure at any point in a liquid is the same in all directions, and it depends on the following factors. Number one, depth or height below the liquid surface. We're calling it H. Now, you realize that pressure increases with an increase in the depth of the liquid and vice versa. Vice versa here means that pressure also decreases with a decrease in the depth. Now, the higher the depth of the liquid, the more the weight of the liquid, thus increasing the pressure exerted by the liquid. Another factor is the density of the liquid. We represent it with a Greek letter rho. Now you realize that denser liquids exert more pressure than less dense liquids. And another one is acceleration due to gravity. Class, you realize that liquid pressure is higher in areas of planet whose acceleration due to gravity is also high. Now, when we go to another planet like the moon, where the value for acceleration due to gravity is 1/6 of that on the Earth's surface, there you realize that the liquid pressure there is quite low. So, acceleration due to gravity is yet another factor affecting pressure in liquids. Now, let us have this experiment that is going to show that pressure in liquids depends on the depth below the liquid surface. And in this experiment, we are going to create three holes, hole A, hole B, and hole C. Now these holes here are supposed to be created at a well-spaced interval, and the holes must be of the same size. Inside, we are going to have water. Now, let us have the procedures laid down. Now, procedure number one is that three equally spaced holes, A, B, and C, of the same size, are made on the vertical side of a tall can at different depths. Then the holes are then closed and the can is filled with the water. Next, the holes are then opened at the same time and the jetting of water from the holes are observed. Now we are going to see the observation. In our observation class, we are going to observe that water comes out very fast and land very far away from the lowest hole, C, followed by B, and lastly hole A. Therefore, pressure at A is greater than pressure at B and C. This shows that pressure increases with the increase in the depth below the surface of a liquid. Now, I would like to invite you to watch this video that is going to help us understand more about this experiment. And it is a very simple experiment, just like I presented. So let us watch this tutorial together here in class. Be very attentive and listen very well. Thank you.
Let us learn through an experiment that pressure increases with depth. An introduction. The pressure exerted by a liquid increases with depth. A liquid exerts the same pressure in all directions at a given depth. The experiment demonstrates how water pressure increases with depth. Number 1. Take a water container. Number 2. Punch holes inside of the container at a gap of 1 inch. Number 3. Fill the container with water. Observe the distance from the container that the water jet comes out of each hole. We get to observe that the water jet from the lowest hole comes out with a great force and falls at the maximum distance of the container, whereas the water from the topmost hole will fall at a minimum distance from the container. We get down to the conclusion that the experiment concludes that water or any liquid exerts pressure on the side of the container, and this pressure increases with the increase in depth. Pressure increases with depth. Pressure and depth are directly proportional.
Thank you very much for watching that video. We realize that pressure is directly proportional to depth. And increase in depth tantamount to an increase in the pressure. And remember, depth is measured, or it is the distance below the liquid surface. Now, I'd like to take you through a very simple and interesting example. Example number one, it says that find the pressure in a liquid of density 1000 kilogram per cubic meter at a height of 8 meter. Remember, we have given us the acceleration due to gravity to be 10 meters per second square. Now, on reading through the question number one, you would realize that the density of water is given as 1000 kilogram per cubic meter, and then the height h is also given as 8 meter. Now we are going to substitute this in our formula that we are going to use to calculate pressure in fluids or in liquid, which is the pressure equals to H rho G. Now where there is H, we are going to substitute with 8. Where there is rho, we are going to substitute with the 1000. And then where there is G, we are going to substitute with the 10. Now when we compute this very well, we are going to realize that pressure is equals to 80,000 Pascal. Let's take another example. Example 2 is saying the pressure of a liquid is 10,000 Newton per meter square. Then, what is the height of the liquid if its density is 1000 kilogram per cubic meter? Given the density being 1000 kilogram per cubic meter and then pressure of 10,000 Newton per meter square, we can get H from the formula that pressure equals to H rho G. Now we are going to plug in 10,000 where there is pressure. H we are going to maintain, but rho we are going to substitute it with the 1000 and then G with the 10. Now when we compute this properly, we are going to realize that 10,000 is equals to 10,000 H. Now when divide both sides by 10,000, also divide by 10,000, we are going to have H equals to 1 meters. Yes. Now, I'd like to invite you to do for me these three numbers. I have given you three numbers. Question number one is saying, calculate the pressure at the bottom of a swimming water pool 1000 centimeter deep. And I've given you the acceleration due to gravity as being 10 meters per second square, and then the density of water as being 1000 kilogram per cubic meter. Please utilize whatever is given here to calculate for me the pressure at the bottom of the swimming pool. Question 2 is saying a diver dives to a depth of 20 meters below the surface of seawater of density 1000 kilogram per cubic meter. You are expected to calculate the pressure experienced. And then lastly, a flask is filled to a depth of 16 centimeter with a liquid of density 800 kilogram per cubic meter. You are to find the pressure exerted by the liquid on the base. Please do this exercise within the shortest time possible. I'll be moving around to check how each one of us easy doing the work. But also, to support you, I would like to invite you to watch the tutorial. Here I have the references for you. You can have this similar information in the Fountain Secondary School Physics Book 2, talking about pressure in the solid, in liquids, mention them. Also visit Comprehensive Secondary School Physics and also go online, and then you have simulations that supports physics. We have very many physics simulations online that when you watch, it will enhance your understanding of physics. I thank you so much, and I wish you a very good day. Bye-bye.